Hey guys, welcome. If you missed live class, let me explain to you today's lesson. Yesterday, we introduced the idea of Punnett squares. We gave you a little practice. In our experience as teachers, students might need a kind of a second day, a little bit more practice, and that's what we're going to do today. So we have a Punnett square practice day today. Let's start and end today with some Harry Potter. Harry Potter had dark hair, like his dad James, but his mom Lily had red hair. Dark hair, capital H, is dominant to red hair, which we use lowercase h allele. So I want to know what genotypes, two dominant, one recessive, or two recessive, are possible for each person. Think about that. James, Lily, Harry, what genotypes are possible for each of them? Think about that and keep going. After our scientist of the day and vocabulary today, we are working on Pear Deck. So there's no breakout rooms. Instead, we're going to be individually working through some Pear Deck questions and getting some feedback right away on them, trying to improve our Punnett square skills. Then we have a few more Punnett square questions for independent work and a quiz at the end of the day. This is Melissa Richter, our scientist of the day. She was a welder from New York. Then in World War II, she was a sergeant, which means she was around. I don't have a birthday for her, you could tell, but she was probably like in her 20s. She was probably born around 1920, something like that. She ended up getting a PhD in psychology from the University of Connecticut, which is a great school, and she started the first graduate degree in genetic counseling. It's the first ever of its kind. She did this at St. Lawrence College in New York City, which is traditionally a women's college. Nowadays, genetic counselors are pretty common. This is like another career you could go into if you're interested in genetics, but you like working with people, you like helping people. Genetic counselors meet with people and they give them advice, they give them options. So here's just a couple of these are like stock photos, but this is kind of what a genetic counselor would do. You would, especially if you were pregnant, this happens often if you're pregnant because you might get a genetic test. It's pretty common to get like a genetic test for your baby. Or for you, they give you a genetic test. They might test for kind of common genetic disorders, and then they might say, "Oh, your baby has almost no chance." Or if you and the dad have high chances, then maybe the baby has a pretty high chance because they know your genes, they know the possibilities for the baby, and they might say, maybe what you want to do is go and talk to a genetic counselor, and then that genetic counselor can sit down and go over information for you, like what to expect if. What are the chances that your child might have certain genetic anomalies? They're not all disorders, but in terms of like the genes that they might have, what might that mean for their lives, for your life as their parents? What options do you have in terms of learning more? In terms of like more education, things you could do to get ready, things you could do to help. And this also works as an adult. If you realize that you are sick and you have a genetic disorder that you don't realize until you're older, genetic counselor can sit you down and do the same thing. So these are people, a genetic counselor, who know so much about genetic disorders. They're experts in these things, and they're experts in talking to people and helping them figure out a really complicated, maybe scary situation that they're going through. So I bet some of you guys out there might be well suited to be genetic counselors, really interested in the science, but also interested in the people part. Really important word of the day, genetic variation. This is in the language of our standard. There will be question about genetic variation on our test. Genetic variation, exactly what it sounds like. The word variation means differences. How many differences? And then genetic, in the genes. So it's the differences in your DNA, the differences in your genes. And therefore, remember, because the DNA gives you your traits, so you might not be able to test the DNA of everybody, but if you see a lot of different traits, you will know that there is great genetic variation. Okay, so we're going to practice that right now. So I'm going to go through, normally then at this point, I would get everybody on Pear Deck. Right now, I'm just going to go through these questions with you real quick. Which flowers, A or B, have less genetic variation for color? I think hopefully really easily you can see that B has less variation. They're all yellow. When A, they're all a bunch of different colors. So there's less differences, less variation in B. What about here? Which family has more genetic variation? for their genes, for their blood type. And how do you know? Family A, look at family A's. There's five kids, or 3 kids, 2 parents. These are their blood types. Mom, these are in family B. These are the blood types. Which family has more variation, and how do you know? I'll go ahead and give you this one as well. These are all the same. There is no variation here. These are very, very low variation in their blood types. They're all the same. Here we have 1, 2, 3, 4 different genotypes. So you could say, I know that family A has more genetic variation because they have 4 different genotypes, AB, AO, AA, and BO, while family B has all the same. So there's more differences in family A, more variation. We use Punnett squares to answer questions about which type of reproduction. Your multiple choice, you're going to know that it is sexual reproduction and asexual reproduction. It's an exact copy. We don't use a Punnett square. We don't need it. We just know whatever the parent has, the offspring is going to have. And so I'm going to make sure that you are going to look at the Pear Deck slides that we post on Google Classroom. So I'm not going to go through each of these questions. I'll read them, but I'm not going to give you the answers. Whose genes go on around the outside? What does each of these boxes represent? The parents have brown eyes. Both, one has big B, while the other one has big B, little b. Fill out the Punnett square and answer the questions below. So you're going to fill out this Punnett square. This is a drawing slide. And you're going to circle for me which is it 0, 25, 50, 75, or 100, which chance that baby will have blue eyes. There's a mistake on this Punnett square. Find it and circle it. Here's the freckles questions from yesterday. The allele for freckles, big R, capital R, is dominant over the allele for no freckles, little r. Sam and Mary both have big R. Set up and complete the Punnett square and answer the question about the baby having freckles. This student made a mistake when filling out their Punnett square. Describe the mistake and how they should fix it. Find the mistake. The mistake is this. They can fix it by doing this. In pit bulls, black noses are dominant to red. We know that. Is it possible for 2 parents with black noses to have a puppy with a red nose? Why or why not? Tell me if it's possible. If you need to, use a Punnett square to help you explain it. To set up a Punnett, okay, so this is just like reminding you, you might not need these slides. I'll click through them real fast. To set up a Punnett square, we put the alleles on the outside, and we cross them through. I left these in here in case you wanted them. Okay, so for today's independent work, we have a few slides for practice and your exit ticket. Write the trait that each pair of genes will produce. So what trait will you have if you have 2 dominant alleles? And you're going to need to know this information. What about if you have 1 of each? Oh, this is a mistake. I need to fix this. It should be 2 little p's. If straight hair is dominant to curly hair and you have straight hair, what genes might you have? There's 2 possibilities. What about if you have curly hair? What genes do you have? And then these are some more setups. Round seeds are dominant to wrinkled seeds. Cross these 2, and answer the questions below. And then Harry Potter. 2 slides of Harry Potter. We're going to keep going with this. So we got these from our genotypes. We know that Lily has red hair, so she has little h, little h. We know James could have big H, or big H, little h. So what I want you to do is complete 2 Punnett squares down here because James has 2 possible allele combinations. So you're going to put Lily on both, and you're going to use James's 2 possibilities on these 2 Punnett squares. And then I want you to circle each one that could be Harry, because Harry has dark hair. Okay, at the end of the last movie, we see Harry grown up and married to Ginny. We know Harry's genotype. Look back here if you need, you circled it. Ginny has red hair. Which genotypes are possible for Ginny and Harry? What Harry's got, we know his genotype. What is it? Ginny has red hair. What is her genotype? Make a Punnett square form and tell me what is the fraction of Ginny and Harry's children that you expect to have red hair. That's it. Take your exit ticket quiz. It's about frogs. And enjoy your day. We'll see you on Thursday.